Ladies and gentlemen, this screencast is about acceleration. And in particular, we're going to do some acceleration calculations and explore a little bit about how we know something is accelerating. So before we can talk about acceleration, we have to review velocity. If you recall, velocity is the rate of change of position over time. So when we know velocity, we know how fast something is moving and which way it's moving. So you have a velocity bookmark that I suggest you review or create a new one for this section and ensure that you're very solid on the idea of velocity. So if we use the approach shown on this page, then that will help us whenever we look at determining velocity at particular points in time. So in this slide, this shows an example of when velocity changes. So we could determine the velocity here, the initial velocity at the start of a race, and the final velocity at the end of the race, and in that way determine the change in velocity. Clearly, we have no motion here, so velocity would be 0, and here velocity is a fairly significant number. So we definitely have a change in velocity shown in this example. Remember that initial velocity is the starting speed, so and its symbol is v sub I, and final velocity is ending speed, and its symbol is v sub f. If you recall, calculating velocity when you are provided with displacement is relatively easy. You've already, if you have the displacement value as shown right here at negative 50 meters, then the initial and final positions have already been evaluated to provide you with just the displacement information. So to calculate velocity in that way, it's just displacement divided by time. So in this case, we have an example of something with a velocity of negative 5 meters per second because this football player is moving in the negative direction. So that negative 5 velocity, negative 5 meters per second velocity lets us know that this player is moving in the negative direction, or in this case, to the left. This is an example of where we are given the starting and ending positions. So here we have to use a little bit more complex version of this equation. Take the initial and final positions and put them in the numerator of the equation and do the subtraction in order to figure out the displacement. So in this case, we have a player that's moving to the right, and we determine he has a velocity of positive 1 meters per second, and that makes sense because he's moving in the positive direction and has a positive velocity. Okay, so that's our review of velocity. Let's go on and talk now about our next concept. Here's a video over acceleration. I'm not going to play this during the course of this video cast. You can pull this up from our website. This is an interesting video that lets you see what happens to the human body whenever in particular pilots or race car drivers are subjected to really, really high accelerations, really, really large changes in velocity. They experience what are called G-forces. And at a certain point, when G-forces become too high, a person's blood pools in their limbs or in their arms and legs, and then they pass out. So this video shows a little bit of some of the screwy things that can happen to people in that setting. Some of it's a little weird, so if you don't like watching these kind of things, don't. So,
it fell to the lot of 2 other Air Force officers.
So here's an example of how it will start, but I'll let you watch it yourself later. All right, so acceleration. So the idea of acceleration is when velocity changes. So if velocity changes, then an object accelerates. So acceleration in physics is a little bit different perhaps than what you think of when you think of acceleration. Typically when we think of something accelerating, a car accelerating, we think it speeds up. But in physics, the definition of acceleration is change in velocity. So when something slows down, it accelerates. Or when something changes direction, it accelerates. So something can accelerate when it speeds up, slows down, or changes directions. Those are all examples of acceleration. You're used to a term called deceleration for slowing down. That's rarely a term that's used in a physics setting. So here in this slide, you can see that the symbol for acceleration is an A. The standard international unit is meters per second per second. The equation shown here in the long form is acceleration equals change in velocity over change in time, or expanded to final velocity minus initial velocity over final time minus initial time. And the short version of this word equation I just gave you is just given here. A equals delta V over delta T, or A equals VF minus VI over TF minus TI. This should look very familiar to you because it follows the same pattern as the velocity equation. The difference is that since acceleration is change in velocity, then we have velocity values in the numerator. Here is a reminder of TF and TI, meaning beginning and ending time. So if we're going to calculate the acceleration of an object, we have to determine all of the values that we need in the formula. So we need to identify an initial and final velocity, an initial time and a final time, and then put that into this acceleration equation. So if we have a situation like this with this car shown in this video, it starts from rest, so we have an initial velocity of 0. It reaches a final velocity of 100 meters per second. We start the time at 0, so initial time is 0, and the final time is 5 seconds. So
welcome
dropping
to
that.
RDU. For your safety, please keep your luggage and personal belongings with you at all times, and immediately notify airport personnel if an unknown person asks you to transport an item.
Bienvenidos a Raleigh-Durham. Para su seguridad, por favor, no descuide en ningún momento su equipaje y sus efectos personales, e inmediatamente notifique a un empleado del aeropuerto si alguna persona
I'll finish up in a second, you guys. Sorry.
le pide transportar un objeto.
So, surprise, I'm in the Raleigh-Durham Airport in North Carolina while I'm doing this. So hopefully we can make it through this without another interruption. So we had gotten far enough to evaluating this equation. We simply need to be very careful about ensuring that we use the correct variable names. So this is initial velocity V sub I. So that's a 0 value. So we look through here, there's V sub I. So the 0 drops in at the end of the subtraction in the top. So you have to be careful about this to ensure that you evaluate these correctly. But making your way through the mathematics on this one, you see that the acceleration in this case would be 20 meters per second per second. This is kind of an odd looking unit, but you can say it as 20 meters per second, or you can call it 20 meters per second squared. Typically we'll use meters per second per second. All right, so in summary, velocity is how fast and which way an object moves at a particular time. And velocity is the rate of change of position over time. Acceleration, however, is how velocity changes. Acceleration is the rate of change of velocity over time. So acceleration is how something speeds up, slows down, or changes direction.
Passengers are reminded that the area in front of the terminal is for loading and unloading only. Unintended vehicles will be towed.
Here's a last video that you can watch if you wish. This one's kind of gross, so don't watch this one if you think you're going to be grossed out, because it does show some folks that get sick to their stomach, and it also, one of the funny things it shows is a vehicle that is moving through, an airplane that is in free fall, and because it's in free fall, there's a dog on the flight, and the dog is not strapped down, so the dog just starts floating around. So that's kind of an interesting aside. It doesn't have a whole lot to do with acceleration, but it does kind of show you kind of an interesting thing about free fall that we'll be talking about later. So good luck. Sorry for the interruptions, and go ahead and do after you've finished your bookmarks, go ahead and do the practice on the practice quiz on vocabulary, and then you'll do some concept practice and then the concept quiz. So good luck.
Under the glatis, hold your air.